Hello everyone. In this video I would like to explain about how distributed objects are used in modern applications. But before that, what is distributed object means? So, distributed objects is a concept in which software objects spread across multiple locations, either on different machines or in a wide network, can communicate and interact with each other as if they were in a single system. And how distributed objects are used in modern applications? In modern applications, distributed objects are used to connect various components or services spread across multiple servers or clouds so that they appear to be in the same system, allowing the system to work efficiently, flexibly, and scalably. For example, for web service, distributed systems are used to connect clients and servers via the internet so that clients can access functions or data on servers, even remote servers. And this is a real-world example of the application of distributed objects. Here, Amazon Simple Queue Service or SQS. Distributed objects are used to manage and process a high volume of messages across different servers. So uh, are what are the role of distributed objects? Distributed objects play an important role in improving the scalability and interoperability of distributed systems. How can, for the scalability, distributed objects automatically divide the workload across multiple servers or nodes so that the system can increase capacity without compromising performance? For interoperability, distributed objects can improve this one because distributed objects use communication standards such as RMI, CORBA, SOLRS, so that each service can interact with each other, like exchange data or call functions efficiently even if they are built with different technologies. Now, this one is technology and protocols in distributed objects, RMI, or remote method invocation. This is an extension of RPC that allows method calls on remote objects. So how it works? You can see here in this picture the the client makes a remote method call uh, sending parameter to the server. The client uses stub objects which acts a proxy for the server object and then sending call over the internet here and receiving the return value here from the server. But and then for the server receive the method call through a skeleton object here which unpacks the parameters and invokes the corresponding method on the server. This here invocation, yeah, the corresponding method on the server, and the server can return the result here, return value back to the skeleton to the client, so the client can accept receive the return value. Okay. And the second technology is CORBA or Common Object Request Broker Architecture. This one is a standard developed by the OMG or Object Management Group to enable interoperability of objects written in different language on different platforms. And how it works? Now, this one is the architecture. Uh, Here, the client use sorry, the client use static IDL, stubs or dynamic invocations interface to interact with the object. Now, this one ORB interface is the core of the object request broker is responsible for handling the communication with the client and the object here. Okay, now it helps in the request routing and managing the interaction between objects. Now, for the server side, here there are two server side. The first one is static skeleton, and the other one is object adapter. Now, the static skeleton, yeah, skeleton interface is this interface on the server side handling incoming requests and are responsible for invoking the appropriate object implementation. For the object adapter connects the object implementation to the server-side skeletons and facilitates the invocation of methods on objects. And here, repository interface repository stores information about the available interface for the object. And for implementation repository, uh, stores the implementation details of the object, okay, of the object. And this architecture, core by architecture, enables the client to request method from a server object without having direct access, while the ORB handles the complexities of communication. Now, this one is a protocol, SOAP or REST. Both of them is both of them are protocols for web service communication, are widely used in modern distributed systems, especially in the context of cloud computing. Nah, yeah, REST is an architecture style. Any web service following REST architecture is called a RESTful web service. And SOAP is a protocol. So, oh yeah, this different, yeah. REST is for architecture style. It's an architectural style, but the SOAP is protocol. A set of rules which must be followed which creating a web service. So, if we want to create a web service, there are rules. Uh, there are rules which must be followed called SOAP. Okay, and there are challenges in implementing distributed objects, but we can solve that with this with the technologies before, like RMI, Corba, or SOAP or REST. Okay, let let move now. The first challenge is latency. This one occurs due to physical distance between servers or high network load. Now, we can solve now. RMI and REST support caching and asynchronous communication to speed up response to solve the latency. And yeah, how the technology can solve the challenge. Okay, and here communication errors. This occurs due to network disruption or lost connections. Now, the technology like Cobra and protocol like SOAP have error handling and automatic mechanism to maintain stability. So uh, we can solve this challenge. Yeah, communication errors. Data compatibility. Systems with different language or platforms have difficulty exchanging data. Now, Corba and SOAP provide standard data formats to maintain interoperability. And the next challenge is security. We, sometimes our data between servers can be intercepted if not secure. Okay, so the technology like SOAP, the I know, the architecture like SOAP and REST, the protocol like SOAP and architecture like REST use HTTPS and encryption to protect data. So that's all from me. Thank you for your attention. Have a nice day.